Micro CPU250 with Ethernet IP. The presentation is about 20 minutes, but if you have any questions at any point, just feel free to put them in. We'll get to them at the end.
Hello and welcome to today's webinar. Today we will look at using the Micro CPU 250 with Ethernet IP. Let us take a look at our agenda for today. We are going to start with a quick review of the CPU 250, and then we are going to go into Ethernet IP, and then we are going to talk about Ethernet IP device classes, and then we have two main use cases we are going to go through today. We are going to go through the use cases where you are using the CPU 250 as your main machine controller and you want to be able to publish data both directions over Ethernet IP. And then the second use case we are going to talk about is using the CPU 250 as a very advanced Ethernet IP I/O block, and there will be demonstrations throughout, and we will finish with a Q&A session. The new CPU 250 is one of our new modular controllers that are part of the Micro series that are great for simple and smart applications. They can do a lot more than just simple applications, but to date, the Micro series are considered strictly of all-in-one controllers or controllers that include a display. The CPU 200 and the CPU 250 shown on the screen at the right, those do not include a display. And today we are going to be highlighting the CPU 250 because of all its great built-in I/O. Now these new modular controllers are loaded with capabilities, lots of connectivity options with Ethernet and USB-C for programming and micro SD, lots of built-in I/O for the CPU 250. You can also add additional I/O through standard OCS I/O blocks that you can add on the side of the unit, and all the connectivity with all kinds of different protocols are supported. And today we are focusing on Ethernet IP capabilities of the CPUs. Now from a built-in I/O standpoint for the CPU 250, it is packed full, and one of the highlights is the flexible I/O, which are 8 specific inputs. They can either be digital or analog voltage or current, 512 or 24 volts. The message for the CPU 250 I/O is there are plenty of them and it is highly configurable. And today, as we previously mentioned, one of the applications we are highlighting is using the CPU 250 as an Ethernet IP I/O block. Now let's start with a quick review of Ethernet IP. What is Ethernet IP? It is one of the most popular industrial Ethernet protocols available today. It is managed by ODVA organization that was created to manage DeviceNet but has been expanded to include Ethernet IP. Now one of the reasons Ethernet IP is so popular is because of Rockwell, which is one of the leaders in terms of market share for automation. They are a big proponent of Ethernet IP and are promoting it. Now one of the areas that we need to up the information on is Ethernet IP device classes, because we have customers calling looking for Ethernet IP support, but they are not exactly sure of what they need. So let's talk about the 4 different device classes. The first device class we are going to talk about is I/O scanner. The purpose of the I/O scanner is to control the network, and you have to have an I/O scanner on every network. And our example here is a Rockwell PLC. The next device class we will talk about is an explicit message client, which is the device that can exchange messages, typically tagged data over the network, usually with I/O scanner. And as an example of that device would be HMI that is sitting on the network. So the next class would be an explicit message server, a device that is sending messages to the network like a barcode scanner. And then finally, we have the I/O adapter class or I/O device, which is the most common class. So for things like AC drives and temperature controllers and valve banks, these are devices that provide information to the network and that are looking to be controlled over the network, or at least exchanged data over the network, but they are not controlling the network themselves. Now let's take a look at all the different classes of Ethernet IP devices and how they are supported by Horner. Let's start with I/O scanners, the device that controls the network. Now if you are looking to the CPU250 to control Ethernet IP network, that is possible, but only if you add a third-party product from a company like real-time automation and interface with that device while that device is controlling the network. Now let's talk about using CPU250 as an explicit message client. This is a device that exchanges messages, typically tag data, with the I/O scanner, which is usually a Rockwell PLC. Now this can be a useful function, but is not all that popular, and here is why. Most Horner customers are OEM machine builders that are using a Horner controller to control their machine, and they sell their machine into the customer's facility. And the only way this data exchange will work is if you have control or access to the program that is running in the processor of the I/O scanner or the Rockwell PLC. And most of the time, OEM machine builders do not have that access. That is their customer PLC, for instance. So while this is a connection that is supported by the CPU250, it is not one that gets used that frequently. So we are not going to spend that much time on that one today. The one we are going to talk about is using the CPU250 as an I/O adapter. In other words, when you are using the CPU250 to control your machine and you want to be able to exchange data over Ethernet IP at your customer's facility so your customer can monitor what is happening on the machine, or maybe your customer can send remote set points or remote control data. That is very common and very capable. A detailed workflow is when you are using the CPU250 to control your machine and you want to exchange data, or you want your customer to be able to exchange data from their Ethernet IP infrastructure to and from your machine. And here is what you need to do. First of all, you are going to program your application into the CPU250 like you normally would to control your machine. Next, after that is done, you are going to get your pencil and you are going to design a map of data that you want to share to Ethernet IP, maybe temperatures and pressures and other status informations you want to broadcast to Ethernet IP. And maybe there are some remote set points or remote control bits or something like that you want to be able to receive over Ethernet IP, or you want your customer to be able to send you over Ethernet IP. So that is what you are going to do. You are designing the map of data that you want to share both directions, and then in Cscape you are going to configure your CPU for Ethernet IP support. And then in Logic, there you are going to have some logic that moves those variables that you want to make available over Ethernet IP, that moves them into the right places so they can be broadcast and received with Ethernet IP. And then you're going to publish what your data map looks like. And then after you ship your machine and it has been installed, your customer will be able to use your documentation and exchange data over Ethernet IP with your machine. So that is the detailed workflow for the first use case. Now the second use case is using CPU250 as an Ethernet I/O block. So the workflow is very similar but slightly different in this case. So first of all, when you are using it as an I/O block, the first step is to get Cscape out and to configure the CPU250 I/O to meet your application. Because remember, this is a highly configurable I/O, and you have got those 8 flexible I/O points. You have got some figurable ranges with your analog outputs. You have got all kind of configuration. So just configure it for your specific application using Cscape, and then again from Cscape add Ethernet IP support to it with a little bit of configuration there. Still in Cscape, you're going to do a little bit of ladder logic to move the I, AI, Q and AQ data that has been allocated for the built-in I/O over to the right places so they can be seen over Ethernet IP. and then you're going to be done with Cscape. Then you're going to fire up the Rockwell software and add the CPU250 as an I/O block into your system. You are going to set it up and you are going to test it. Now in this scenario, remember what we are doing is we are sending our input data from the CPU250 out over Ethernet IP, and the data we receive in from Ethernet IP we are going to map over to %Q and %AQ data. So we have got a total of 19 words that we are producing. That is our I's and AI's, and 26 words we are consuming. That is our Q's and AQ's, and all that data is what has been allocated to the built-in I/O of our CPU 250. Let's take a look at what is happening on the bench. So here is our CPU 250. It is wired up to our I/O stimulator. Now this happens to be a first generation model. It works with exercising the I/O, the digital inputs and outputs, analog. And then over here we have an old battle axe Rockwell compact Logix, where we have got a flashing light because the I/O is not working quite right at this stage. But for our purposes, we're just testing the Ethernet IP and demonstrating that for you. So this is an Ethernet IP I/O scanner, and this is how it is acting. And then our CPU 250 as an Ethernet IP I/O adapter. Now in the use case that we are demonstrating, we are going to turn the CPU 250 into an Ethernet IP I/O block. Now this is probably not your use case. You are probably going to want to use the CPU 250 as a machine controller, and you want to have some of your machine data available over Ethernet IP. Well, despite the fact that your use case may be different, this demonstration will give you all you need to know so you can successfully implement Ethernet IP for your application. So the first step, we need to configure the I/O on the CPU 250 for your specific application. So we are going to go to hardware configuration and go to local I/O tab. Now the CPU 250 built-in I/O is highly configurable, and we need to configure it for your application. So on the input side, you might have high-speed counting that needs to be configured. We have configured some here, so you would configure that under digital input. On the digital output side, you may need to use a couple of high-speed outputs, maybe as a stepper, maybe for a PWM signal, maybe as an output that fires based on encoder position. So those would be configured here. On the flexible input side, this is where all your analog inputs are configured that you have. You might use them as digital inputs, depends on the application, so you would need to configure those here. And on the analog output side, you have got 4 milliamp and 4 voltage analog outputs that need to be configured for a signal type as well as the data range. So all that configuration needs to happen now, regardless of how you do the configuration for your application. The way we have designed this example application, all the IQ, AI, and AQ data for all that built-in I/O will be available over Ethernet, regardless of how you have configured your specific application I/O requirements. So that was the first step. The second step is to configure Ethernet IP, and we are going to go back to the hardware configuration to do that. So we are going to go under LAN 1 config, and we are going to make sure our IP address and net mask are configured, and we are going to make sure our Ethernet IP I/O adapter is selected and highlighted, and then we are going to hit configure selected protocol. This is where we determine what data we are producing to Ethernet IP and what data we are consuming from Ethernet IP. So from the standpoint of the data that we are producing, this is considered Ethernet IP input data, because this is the perspective of the Ethernet IP I/O scanner. So the input data from the perspective of the scanner, in our case, is 19 words of %I and %AI data that is allocated to the built-in I/O. Now where is that data coming from? Well, it is coming from I and AI, but we have to put it in this array here, and we have got a 19-word array where the I and AI data elsewhere in the program is going to be pushed into, and then that data is going to be broadcast over Ethernet IP. Now coming back the other direction is going to be 26 words of Ethernet IP output data from the perspective of the scanner. That is going to go into this array of 26 words, and then elsewhere in the program we are going to take this data and push it into %q and %aq data to get the data going that direction. And then finally we have 1 word of Ethernet IP status. What does that do for us? Well, the lower byte of the status word, if it is a non-zero, tells us there is at least 1 Ethernet IP I/O scanner that is controlling the I/O. So as long as that we have at least 1 I/O connection, we know the I/O is being controlled and we can allow the normal operation of the unit. If the I/O is not being controlled, then we are probably going to want to turn on our %q and %aq data all to 0. So that is the Ethernet IP configuration. That was step 2. Step 3 now is to move the data around appropriately. So let's start with %i and %ai data that we want to broadcast to Ethernet IP or to publish to Ethernet IP. So the first 3 words of the array that is going to be published to Ethernet IP consist of %i1 to %i48. Those 3 words of %i data that are being allocated to the built-in I/O. That is the first 3 words in the array. The last 16 words in the array come from %ai1 to %ai16. So this is the data that we are publishing to Ethernet IP. Now in terms of consuming from Ethernet IP, here is the array of 26 total words that is receiving the data we are consuming from Ethernet IP. The first 2 words or 32 bits of the data that we are pushing into %q1 to %q32. The last 24 words we are pushing into %aq1 to %aq24. Now you will notice we have an either or logic going on here. So that is where we determine that either or is going to depend on whether we are being controlled right now by Ethernet IP scanner. How do we detect that? Well, we look at the lower byte of the Ethernet IP status. If it is greater than 0, we know we are being controlled and therefore everything is okay. If everything's okay, we are going to go ahead and push that data we receive over Ethernet into our %q and %aq registers so that we can control the I/O. If we are not being controlled, that data is old, so we are going to put zeros in all the %qs and %aqs that have been allocated for the built-in I/O. So this is the logic that we have got here for step 3, and the next step is to fire up the Rockwell software. Now that we have configured the CPU250 for Ethernet IP, let's see how quickly we can get it added to Ethernet IP network. So here we are with our compact logics from Ethernet. We are going to go ahead and right click, hit new module, and this is where we are going to add the CPU250. Now we need to search under generic module. We want to give it a logical name. This will be the basis for all the automatically created tags. We are going to call it CPU250. The mapping works much better if you use integer as your basis for your data. We will type in the IP address for the CPU250 here. The input instance is always 100. The output instance is always 101. And the configuration instance is always 3. Now for our specific configuration, we have 19 input words. From the CPU250 to the Ethernet IP, we have 26 output words going the other direction and 0 configuration words. We hit OK and go from here. So let's go ahead and go online because right now we're offline. So we have to connect to the controller. We need to download the changes we just made. We will hit download here. Done downloading. Change the controller mode back to run. Press yes, we will. So let's see where we are at. So the CPU250 is now running and we have some additional tags that have been added here automatically. So let's take a look at the input tags. Let's expand those here and look at this. We have live data, so you can see data that is changing here. So let's flip a couple switches on our I/O stimulator here so we can see those changing. Remember, the %I digital inputs are mapped to the first word here. Here are our two analog inputs. Let's go ahead and exercise the first one. You can see it is going up quite a bit, over 20,000. The second one we will make is go lower. We can see it go below. That is all updating nice and quickly. And then the number here represents our encoder. So let's count up. We have got live data that all looks good. Now that is on the input side of things. Now let's take a look at the output data. Let's expand that here. Here we have all zeros. Remember, this data is going the other direction. Let's change this to value of 255. Remember, this is where our first 8 queues are mapped. We will hit enter. And now, if we switch over to our overhead view, we can see that all our LEDs are on. So if we do the binary math, a value of 255 will turn on all those LEDs. Now on the software, we are going to change that to a value of 128. And when we do that, all the LEDs but one should go off. We're going to hit the enter now and you can see that happened immediately. That concludes our webinar for today. Thank you so much for listening and the Q&A session will begin shortly.
Okay, so we'll be following on with the CPU250 next week again. The registration link is up. That video will be migrating from the RCCs. I don't see any questions in on this week, so I think we can leave it there. Thank you all for joining us, and we'll see you next time.